We ready to get started? Started on the second to last unit. And actually, these two are going to be related. So we're going to discuss statistics, sort of an introduction. We're going to look at things like where's the middle of the data, mean, median, mode, how spread out is it, standard deviation, and the 5-number rule. And then next week, we'll get into something called the normal distribution, which is used a lot in statistics, in education, unfortunately, the bell-shaped curve type thing. If you've heard of those types of things, that's what we're going to be looking at as we go forward. So I do have links to the PowerPoint slides in there. I updated those. Those were not there, but I located everything. And so this first part is, let's see if I can, yeah, good, everything's working. There we go. First part will be mostly definitions. I guess before I get into this, though, what I want to show you is in the modules, and actually I'm going to pull this up. I have a link to a statistics calculator. So I'm going to open that up. When you're going through the homework, notice here's to enter your data set. You can actually, and when we go through the quiz, I'll show you, you can actually just copy the data, paste it in here. It will do all the calculations for you. Everything we're going to talk about will get calculated for you. So this presentation is to just give you the feel for what's happening mathematically, but you won't have to get into the weeds and the grass and dig down and actually do all the calculations. It's going to get done for you. But I want you to understand why one way is different than another way. Okay. But I think you're going to get a better feel for what they are just by getting the calculation and then comparing the numbers and not getting all tangled up as I get this and then I subtract this and then I square it and then there's a few calculations in here that are just very convoluted, but I remember learning it that way, but I never really understood what that number is that I got. So I'm going to teach it in a way where we'll just let you get the number easily, and then we'll focus on what does that number mean. Okay. If you take a class in the future where you actually have to calculate it, it's not bad, especially once you understand what it is. But trying to do the calculation gets in the way of understanding. From my perspective, other teachers believe differently, and that's fine. Everyone's is entitled to their opinion. But this is Little Crow's opinion. Let's just use the numbers. Okay. So this first part will be a lot of explanation about things, and even the second part, and then how we're going to have you do it is when we get into the quiz. I'll show you how to use that calculator. Okay. So we're going to talk about sampling, frequency distributions, and graphs. What sampling is the reason we do statistics is we want to understand something about a group of people, let's put it, or animals or whatever, some group we want to understand about. What's the average height of a person, maybe? Is this group taller than that group? Those kind of things. All sorts of, what's the prevalence of diabetes in a population or something. So the population is all the people we're interested in knowing, but as you know, there could be a lot of people. If you want to know what's the average American diet, well, we have 300 million, maybe 400 million people. You don't want to go ask all of them. You ask a sample. So, and what we're going to find is these tools are actually, you can get pretty accurate results about what a population is like of 300 million by sampling as little as maybe 30 to 60 people, actually, if you do it correctly. Okay. So what is statistics? We use the word in two ways. It is statistics. When we talk about statistics, we're also talking about the science or how do the methods of collecting, organizing, analyzing, interpreting data. But it's also, we use that word to refer to the data itself. You might hear people say, don't be a statistics. That means they don't become part of the data. Don't get in a car accident or whatever. Don't be a drunk driver, whatever they're saying. If they say, don't become a statistic, that's kind of what they're meaning, is don't become part of the data. But when we use that word, it means both ways, the data itself and how we analyze the data. Descriptive statistics, those are um, used for summarizing a population. Like the first thing I said is, what is the average height of a person in the US? That would be a descriptive to describe a group. Inferential statistics are so that we can make generalizations. So maybe in this population of tall people, what is the probability, or what's the likelihood that their child is also going to be tall? That's inferential, trying to predict the future. So we use it in two ways. And this is what we talked about. The population is and we'll just use it to people, but it could be, cell phones and maybe you're in quality control and so your population might be all the cell phones produced or something. But whatever it is, it's all the objects that are being analyzed. And then what we do, generally we'll take a sample, a smaller subset, and we'll see how that's working. And if we do the math right, we can oftentimes make accurate predictions about the population itself. Okay. And a representative sample is the way we do it. You create the sample in a way that it represents the population, so it's mixed. You wouldn't just go in and, if you're trying to find something about the U.S. population, you wouldn't just go someplace that only has men or only has women or only has teenagers or only has seniors. You got to get a mix, and that's how we get a representative sample. One of the beliefs is that we can get a representative sample by randomness, doing something random. And typically we will get a better sample with randomness. It's not set up quite right, so we're giving you the answers as we ask you the questions. But we'll go ahead and do this. So a group of hotel owners in a large city decide to conduct a survey among citizens of the city to discover their opinions about casino gambling. So they're just wanting to know whether they should open casinos in their hotels, right? So what would be the population? Would it make sense that it's all the people in that city, right? All the citizens of the city, not visitors, because they just want, they want to know what the people who live there want. And so what would be a good way of getting, one hotel owner suggests obtaining the survey by surveying all people at 6 of the largest nightclubs in the city on a Saturday night. Each person will be asked to express his or her opinion. Do you think that would be a good idea to get a representative of the city going to a nightclub? What kind of people are going to be at a nightclub? Maybe people who are more likely to want to have a gambling casino because they're out late. People who maybe don't like it, they're already in bed and they're not at the nightclub. So you're right. So that's going to the nightclubs, you're going to get a very biased sample. Of course, sometimes they do this because that's what they want. Well, everybody agrees that we should have casinos. Well, everybody at the nightclubs because they want something to do at night. Okay. So this is where we get into a random sample, is that everybody in the population has the opportunity to become part of the sample. So how you go about doing that is part of a fuller statistics class, which many of you may take, especially if you go on to a master's degree. Most master's degrees will have you take some kind of statistics class because they want you to understand how to do all this stuff. So you basically have a computer assign everybody a number, and then you have the computer randomly check, pull out numbers, and then that's how you get your sample with that randomness. You have them roll a die or something. There's with the element of randomness, generally you will get a more representative sample. Okay. And so here's a second way. Instead of going to the nightclubs, randomly survey people who live in the oceanfront condominiums in the city. So many hotels lie along the oceanfront. These people might object to increased traffic and noise. So again, going to a particular area is going to get you a biased result. Survey the first 200 people whose names appear in the city's telephone directory. Well, who are you going to get? All the people with last names of A or B, right? Depending upon how big the city is. How about randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods? So you'll get a mix, cross-section. Each neighborhood has the opportunity to randomly be selected, and then each person in there has the random opportunity to be selected. And that's one of the problems we see with a lot of times. A lot of surveys are done online. Well, who are you going to get? People who are online. You've got people who came to a site or something. So you're going to, and as we've seen from the last election, different sites have different populations of people who are attracted to them, where you get your news and such. So next, we're going to talk about a frequency diagram or frequency distribution for this data. And one of the ways we do that is this is just all the raw data. So what we do is we go through and we say, okay, these are 35 boys and their ages, age of maximum growth. And so then we list all the ages, 10, and if you look over, it's 10 to 18. And we count the frequency, how often that age occurs. So there was one that their maximum growth was at 10, 2 at 11, 5 at 12. And so this is giving us the frequency, how often, how many people are in each group. And we can see that, well, 14 had the most. And then what can we do with this information? We can, taking this information, we can just view it as it is and say, okay, yeah, 14 was kind of that had the most. There was someone out at 18. There was someone at 10 that, at 10 years, that was their maximum growth, 18 maximum growth. So we kind of see how it's spread out and grouped around 14. We can also do a bar chart, which we'll look at those in a moment. Here's another sample. Here's a class of 40 students and their scores on an exam. Another thing we do is sometimes with a lot of different scores, what we might do is we might group them by scores of 10, so 40 to 49. And I'd go through here and pull out like 47 as one score. That looked like it's kind of a tedious way to do it, but you've got to just basically count which one is in each of these classes, or sometimes these are called bins, data bins, right? And we just count and we get, again, the class would be, well, I guess I've got it here. We'll start it, but we won't do it all. Oops, I forgot to get this started up again. Driver. So again, we would come here and say our class is 40 to 49, and I see one piece of data. I have to go through and just make sure there's nothing else. Oh, there's a 45 there, so there's two pieces of data. And we can use tallies to go through that, and then 50 to 59. So, I had two tallies there, so I might also write the number 2. All those in 50. Bless you. 54. You can just kind of see right, oh, I missed 43. So then I went back and, okay, there's not 2, there's 3. 56, 57, 50, and 59. I get 6 there. And again, the biggest thing that can happen is error in counting or something. So it happens. But, we could make this frequency chart, again, using bins. And here we are. What we do is we add all the frequencies together, and yes, we indeed have 40 students, so that's what we knew we had at the beginning, so we know we got everybody captured. And again, we could just review this and say, okay, the average looked like the most scores were in the 70 to 79 range. There's a few higher, a few lower, those kind of things. We can't just look at the frequency table itself. We can also do a histogram. So this was on those age of growth for these boys from 10 to 18. And then again, so you visually see that, yeah, at 14, that was the year of the most of the people had their most of the boys had their maximum growth. So you'll see this is called a histogram, where they're just doing it by number on here of how many there were. Okay. You can also do a frequency polygon, which would be a line. And so what they do with this is they kind of get the midpoint here, and they connect those points with a line to sort of get a trend line. And that can be a little confusing sometimes, because you sometimes look between here, but that really has no meaning. They were either 14 or they were 15 when they have these. So I like the histogram better, but sometimes you'll see this, and what they do is then they erase the histogram and just leave the line chart behind. But the problem with the line chart, when all you see is a line chart, you start thinking that these values in between have some importance when they really don't. They're just connecting points that we actually have. Stem and leaf plots, we can do that off of the table. So I'll show you one here. Again, we would maybe choose a stem to be 40 to maybe 49. And again, we would count how many there are. Actually, with these, what they'll do, this is kind of a cool method, is they'll say this is the 40s, right? And so the stem is the 4 part, the leaves are the digit part. So I could say there's a 7. There is a, this is different, there's a 45 here. So I'll put the 5 here. And there's a 3 here. Good, I left enough room. And that's all the 40. So you could kind of see there's a 43, a 45, a 47. And if you do this for all of these, you'll see the one that has the most will have the most leaves out here. But you can also reconstruct the data from these stems and the leaves. Okay, so the 50s would go here. And again, we kind of go in order, the digit of the 50s. So here's a 57, and I'm going to put it out here, but you kind of have to get them in order first, because you want to make sure you get all of these stems sort of in the right place. There's a 56 goes there, another 57, so there's 2 7s. Here's a 50, so there's a 0 here, and there's a 59. And notice I've got too much space, so I can't really compare to this, but if you link it all up, as I think I've got on the next page, yeah, that it would look something like this. Now, there's another way you could do it without putting it in order, just kind of randomly going, and it gives the same sort of picture of which one has the most, and you can still reconstruct it. But personally, I like if you put it in order, then you can see within each of each stem, you can kind of see a 43, 5, a 47. It just, to me, it looks better if you can order the numbers, but not necessary. Okay, doing so good so far? Again, a lot of this we're just exposing you to, so you can see these different methods. And we're almost finished with this part. We've got a second part where we'll look at mean, median, and mode. But mostly this is, when we look at charts, there are ways that the advertisers or the people who are giving us the data, they have built-in deceptions. They want us to think something's really important when it's maybe not so important. And one way of doing that is, and sometimes they're just trying to fit it on a piece of, well, either a paper or in a website to get the sizing right, one of the things they do is they break graphs. So notice this break, it doesn't start at 0, it starts at 11.3 and 2.9. What this does is it amplifies the difference. So 11.7 to here is really just 1 percentage point. It wouldn't look as drastic if the scale was going from 0 to, say, 13 or 14, because then you'd have all of this and it just would not look as drastic as it does. Okay. It would look more like something, and then if you spread it out, notice this is the same data going from 11 to 19 instead of zooming in on it, and it doesn't look like a big difference. Okay, so it just depends on what you're trying to do. If you want to emphasize, and again, we saw this in the politics, people were not lying necessarily, but how they presented their facts made maybe a small problem look big, or maybe a big problem look small, depending upon what they're doing. Percent of unemployment or percent of inflation. Again, if you zoom in, you can make it look like a big problem. If you zoom out, you can make it look like a small problem. And so those are some things that, and it gives you that impression. So just look for those on the graphs and just know that they, you can see this now. What you got to do is you got to step back and reason. Is this really important or not? I realize this person is trying to make me think this is a big difference. So I take their bias into consideration. And I realize this person over here, whoever did this one, is trying to make it look like there's not that much difference. So I realize they're biased too. And maybe the truth is somewhere in between. So that's what we're trying to get you to. So watch for things like titles. Sometimes they just throw you a picture and make sure there's a title. Look for the numbers that are lined up. Have they zoomed in or zoomed out? What is the scale like? Just kind of, be good consumers. And we're going to look at a couple where they make them like pictures. And so sometimes that design can distort the data and leave a wrong impression. So our bar sizes scaled proportionally in the terms of the data they represent. Because here's another thing: is if there's a larger one, what they do is they go both the height and the width, and it ends up making the area actually a lot bigger. So something like this, what they really are showing is the square footage of a house, number of square feet of an average U.S. single-family home from 1980 to 2010, that it went up. But the problem with this one is it's not just these top parts. They've also widened this, and so it makes this look even larger of a difference because you're getting area which is squared. So you're squaring the difference, and it gives an impression of a greater difference than if you were just looking at the numbers themselves. Okay, so yeah, it has gone up if we just looked at this as a line chart, but then when you look at this, it gives even a bigger impression. Okay, and again, we say, okay, there's a little deception going on here. They want something. Maybe I agree with it. Maybe I don't. But and maybe it's just one of those things. Okay, so that's that one. Discard, and then there's a second PowerPoint, and this one we're going to get into the mathematics. And again, I want you to just listen to how these calculations are done. We're going to, when we actually do it ourselves, we're going to use the calculator to do the calculations. Okay, one of the things we're interested in is statistics. To describe statistics is what's the average, what's the middle. And there are kind of two ways of finding, or three ways really, of finding the middle. One is the mean, and this is the arithmetic middle, which means this little symbol here is a sigma. It means we add all the data together. So we're going to take all the data points and add them together and then divide by however many there are. So if we have, like on that last one, there were 40 exams, we would divide by 40 after we added all the exams, exam 1 plus exam 2 plus exam 3 plus all the way to exam 40, we would add them all together, divide by 40. Okay, and that's where it's a tedious process again. And if you're doing it with a handheld calculator, it's very prone to error. So what we're going to do is we're going to copy and paste it into a calculator that will do this for us. But notice it's going to be adding and then dividing by that number. And we're going to talk about, we'll talk about the next one anyway. So calculating the mean, we can go through again and add all the data together. And this one is a little wordier, but we'll go to the next one. So you pick out the pieces of data. There were 10 countries in there. These are percentages. We add them all together. We've got 799 divided by 10. So the average was about 80%. 80% what? Let's see what are inventors born or made? So inventiveness can be learned. So about on average, 80% of people believe that inventiveness can be made, that you can learn to be inventive in these 10 different countries. Again, there's a different, some are up at 92, some down at 75, but what we've gotten is the mean. Now, they have this arranged from largest to smallest. While we're here, I'm going to introduce the concept of the median, which is another way to find the middle, and it's actually the way to find the exact middle. So since there's 10 pieces of data, what we want is the one in the middle. So if we go 1, 2, 3, 4, 5, and from the other end, 1, 2, 3, 4, 2, 3, 4. There's supposed to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. They missed something, didn't they? There's supposed to be 10 there. And I just thought but there's not. There's only 9. So maybe hopefully they calculated it correct. I haven't added this together, but well, let's do this. Since there's only 9 numbers listed here, the median is going to be 1, 2, 3, 4 on this side. 1, 2, 3, 4 is going to be 78. It's the middle number. Now, had there been 10, like they said there was, in fact, let's see if we can come back here. 2, 7, what did they miss? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So who did they miss? There's 1, 2, 3 77s. And they only have 2 77s. So there should be another 77. Hopefully they added it up right. But with that in mind, what we do now, so if it's odd, which 9 is an odd number, then we just find the middle. If it's an even number, like we were supposed to have, the 77, become 1, 2, 3, 4, 5, and 5 from the other. The middle is actually right here between 2 numbers. And so we go halfway between them. So that would be 77.5. Or you add them together and divide by 2. That's going to be the same result. It'll get you halfway between the 2 numbers, 77.5. And then you can compare which, so that the mean is different than the median. How where the middle is a little bit different, and that can happen. What we're going to see is, what if I had one group that said, 100% believe that inventiveness is born? What's that going to do to the mean? Well, it's going to move it up, isn't it? Because I added 8. So the mean is more sensitive to either really large or really small values. They can either pull the average down or pull it up. If I'm doing the median, it's just one number that gets counted. I'm still going to have about a median of 78. The median doesn't get moved as much, is not as affected by what we call outliers, those pieces of data that are either really big or really small. And that's why in like the housing market, if you've ever heard talk about that, how home prices, they always use the median home price. Because if you have a median of say 300,000 and somebody comes and builds a $10 million estate in the middle of that neighborhood, that would move the average price. It might say, well, now the average price of a home is $1 million, but it's really not. There's a $10 million house and a bunch of $300,000 houses. So the median would stay the same, but the mean can get changed by what we call outliers. Okay, so we'll look at that. And what I want you to do is by doing these calculations, you'll see, but be watching for that. Is the mean and median about the same? If they are, okay, the data is pretty homogeneous. It's pretty much the same. If the mean is either much higher or much lower than the median, then what we know is we've got some outliers. We've got some pieces of data that are either really small, one or two of them, or really big. Okay. And we're not going to get, again, too much into how to calculate for from a frequency distribution. That's sort of a weighted mean. I believe our tools will handle those. We'll deal with those as we come to. Okay. And again, this is from another textbook. So these slides are here. I don't believe in our homework we have that. So we'll come back to it if we need to. So don't worry about getting the mean of a frequency distribution. The median we just talked about, it's the data in the middle. And the way I remember it is if you're going down the freeway, what's in the middle of the freeway? The median. So it's physically in the middle. The median is that middle number. The mean is we add them together and divide by however many we have. That's the arithmetic measure, and it can be pulled either up or down by large or small pieces of data. Median is oftentimes used to get that middle number. So the one thing though, I saw someone was already working ahead, which is great. We could go here, well, there's 5 pieces of data, so is this the median? Because it's the middle number, but it wouldn't make sense because I could randomly put the numbers in a different order and it would be a different median. So the thing you have to do is put it in order first. So we have to go 84, 88, 90, 95, and then 98. Then we see the median for this group is 90. Okay, so just put it in order, and it could go largest to smallest. It doesn't matter, but they just have to be in order of size. And then the middle number is the median. Okay, so that's the first step. Always arrange. Yeah, it's nice if you could just pick the middle number, but if it's randomly organized, the median becomes a random number. So that's not good. Okay. And the nice thing is the tool that we're going to have you use will do all of that for you. So, putting 25 numbers in order, that's tedious, right? We're just copy, paste it in, and the system will do it for you. Okay. Find the median, continued. Again, we need to put it in order, which they did for us. And in this case, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's an even number. The median would be in the middle. Again, halfway between 28 and 34. You could just kind of eyeball, and that's going to be about 31. Or you can add them together and divide by 2 is just the calculation that gets done, and that gets you the middle number as well. So notice 31 is not actually a piece of data, but we would call it the median. It's a calculated. So it's kind of like the mean of the when we have even, right? The mean of the 2 middle numbers. And again, if we had one more piece of data, so if we had 11, then we would have a middle piece and we just use that. We don't have to calculate. But again, it is really a location versus a calculation. Okay. And this will shows you a method that you can kind of go through. So if you have 9 places, 9 plus 1 divided by 2, you go to the 5th place. Again, we're going to use the calculator because we just want to focus on the fact that the median is that middle number, and it's less likely to get pulled one way or the other. And a lot of times we just need to compare what's the median and what's the mean. And if they're very close to each other, then that tells us something about the data. Okay. And again, I don't think in this homework we're doing frequency distributions. If we are, what we would need to do, and this one we can do, is we get the total, and this one that it tells us that there's 151 data items. Okay, so where's the median? Well, you can do that same thing, add 1 to the data, divided by 2, so that's 152 divided. We just need the 76th position. So we could count, there's 2, 3, 6 and 12 is 18. We keep counting until we get to the place that has the 76th position, which I believe, I could be wrong, will occur about here. If you add all these numbers, somewhere in here will be the 76th, so we'll be in the 7th. It might be the 8th. I haven't added all these numbers. Maybe I should. Let's see. Because we're going to divide by 2, it always gives us an even number. And so, yeah, it means that there's out of 51, if we cut it in half, we would get, if you didn't add the 1, you would have got 75.5. So then you could do it that way and say, well, just round up to the next one. If we had started with an even piece of data, say 152, then what we would do is we'd do this, but then we'd have to say it's halfway between these two. Yeah, and I think it was. So it got to the 76. If you were to lay all these out, as you add up, this last one, we're over 76. So the 76 one is somewhere in this grouping. So we could say that 7 is the median. Because there's 76 here, and then there's another 76 on this side. Okay. And this is where, again, we're going to go through and have the calculator do this for us, but we'll just look at this example. And this is a place it gets used, is in labor negotiations. So you have your employees. They have salaries of 19, 20, 21, 22, and 23,000. But the president or the manager has an annual salary of 95, much higher. And so when you want to go to negotiate, notice the manager would like to maybe look at the data. These are all my employees, or the owner, somebody, and they want to add that 95 in because that's going to increase what the average salary. I think when we throw that in there, let's just do that one real quick. I'll do 19,700 plus 22,600. Wait. 19,700 plus 20,400 plus 21,500 plus 22,600 plus 23,000 even plus the 95,000, 202,000 total divided by 1, 2, 3, 4, 5, 6. So we get an average salary, if we use the mean, 33,700. But are any of his frontline workers making that much? No, but yet it sounds, oh, I'm paying an average of 33,000. It's not a lie, but it's, well, it's maybe not the truth either. Yeah, and when the union goes to negotiate, which one are they going to use? You're only paying an average, which is more accurate, because these are your workers. Your average 22,000. So don't throw in the manager salary, because that's why they negotiate separately, right? look at that median. And this would be a place where you say, wait, there's a big difference between the mean and the median. Somebody is not lying, but they are trying to get some bias in there. Okay. And actually, I should have just waited, because on the next slide, they actually go ahead and do that for us. So the mean is got this, what we would call an outlier. And again, a lot of companies are that smaller companies. You got the president who's making most of the money. You've got your frontline workers who are making substantially less. And again, that might be fine, but let's just look at it as it is. Finally, the one other thing is the mode, and the mode is just the one that occurs the most. And sometimes this is used oftentimes when the data is not numerical, something like the color of a car. How could you calculate white plus green equals what? No, you can't. Colors of cars, you just count how many colors, how many cars of each color, and then sort of the average color would be the car that has, that appears the most, the one that happens the most often. Okay, so in this one, in our data set, we would say the mode is 7, okay, because 7 appears twice, and there's other ones. You could calculate, you could look at this number. If you went for the median would probably be about 7 as well, right? 2, 4, 7, 7, 8, 10. So 1, 2, 3, 4, 5, 6. Halfway between 7 and 7 is still 7. So the median 7, the mode 7. And I think if you add this together, you'd be probably close to 7. So all of them could be the same. So it does appear that 7 would be the middle number. However, if we had 3 2s, that could be the mode as well, right? But it's telling us where most of our data is. There's also another method that can be used, and you'll see this in the calculator. We'll do this for you. The mid-range, you take the lowest value and add it to the highest value, divided by 2, and that gives you so that you have 500 pieces of data. You don't want to add them all together unless you've got a machine that can do it. So you take the lowest and the highest, divide by 2, and that gives you a feeling for where the middle is as well. And they call that the mid-range. Okay. And that comes from the lowest to the highest is your range. So here's the range. Dividing it by 2 gives you the middle of the range. And again, we could go through some examples, find them. But again, we're going to get our data, our calculator to do all of this for us. Okay. The next concept, so that's the middle of the data, mean, median, or mode. So again, we'll use our calculator to do all of that. The next one is how spread out is the data from the low to the high. So one way is to use that range. We just use the range for the mid-range, but the range itself is you just take the highest minus the lowest, and that gives you sort of the spread. So we could do it with temperatures. Hottest day is 89, the coldest day was 61. If you subtract the 2, that gives you a range of about 28 degrees from the low to the high, giving you a feel for how spread out that is. Okay, one way of getting sort of the spread of data. And again, it's just the high minus the low, and that gives you how spread out things. It's a quick look at the spread. Standard deviation. This is the one that is a very complicated calculation. I'm just going to go through the steps so you kind of understand how it's being done. With standard deviation, and we will use this a lot in Chapter 12 as well, is we are going to, first of all, start with the mean. So this X bar is how this is read, and it's the mean. So we add all the data together, divide by how many there are, and that gives us a mean. So in a way, arithmetic middle of the data, right? Then what we're going to do is we're going to take each of the data items themselves and subtract the mean. So what we're getting is the deviation from the mean. Okay, so that's a standard, the deviation part. How far from the middle point is all the data? We're going to try to average that out. Now notice if you were to take these deviations and add them all together, you get 2 plus 1 is 3, plus 0 minus 3, you'll get 0. And the thing is that will always be the case because that's how that calculation worked. You added them together and divided to get the average number. And what it does is half of the weighting is above and half is below. So if you just add those deviations, they always cancel out. So that's why this next step in the calculation process is sort of a manipulation of the data. What we're going to do is we're going to square each of these deviations. 2 squared is 4, 1 squared is 1, 0 squared is 0, and -3 squared, and do it this way, is going to be +9. So it turns all the numbers positive, first of all, because if you square a negative number, it becomes positive. Now we can add these together, find an average, and then what we do, after we get that average, we're going to take its square root, which unsquares them, and that's what we call the standard deviation. So it's getting sort of an average difference between the middle, the mean, and the date in each data point. Okay. So you take the mean from each data, you're going to square it, and the reason we have to, because otherwise we just get 0 every time. We add all of these together. That's what that sigma means. That's a Greek letter, just means add all those things together, shorthand. Once we add them together, we get an average, but for some reason, they found that not quite all of the numbers. So if you had 10 numbers, you would actually divide by 9. If you had 27 numbers, you'd divide by 26. That it gets a little bit more accuracy as long as you have a sample. So this is for a sample, because if you're less than 30. If you have more than 30 pieces of data, this doesn't really make a difference. So they have two things. They have a sample standard deviation, and then they have a population standard deviation. Calculation's a little different. One divides by n, one divides by n minus 1. The thing is we won't have to worry about it because the calculator takes care of that for us. So again, it's a very complicated calculation and prone to errors. So we're not going to have you do it, but I wanted you to understand it, that it's sort of a manipulation, but it's taking the mean and figuring out about, on average, how far is each piece of data. And so the bigger the number is, the more spread out it is, right? The smaller that number means our data is more tight. And I might liken this to the ages of people in our classroom. If you're in a high school classroom, I bet you'll find most of those students, their ages are within 1 year of each other, right? Because that's how we do high school, right? You're a senior, you're either 17 or you're 18. That's about it. Maybe there's a 16, but there's not that much spread. I've had a community college class where I had a 12-year-old and an 80-year-old in the same classroom. Quite a spread, okay? And so that standard deviation would be much larger. It might be like 20 years, that standard deviation for that community college classroom, whereas in the high school classroom, the standard deviation is maybe half a year. On average, people are, so that's what it does. And that's what I want you to get, is not to focus on calculating, but what does that mean? Okay, so again, you at least see how it goes. You get the data, you take the mean, you subtract it, you square it, you add all that data together, and then we're going to divide, in this case, 1, 2, 3, 4. We're going to divide by 3. 4 minus 1 is 3. And then at the end, since we squared everything, we're going to have to take the square root of that for it to have any meaning, which undoes this sort of unnatural or unaccounted for manipulation. So we square it, but then we unsquare it. Okay. And we get two things. Sometimes we'll use this number, or you'll see this number, but again, it's usually an intermediary. We're looking at, okay, on average, each piece of data is about 2 away from the mean. And if we look back here, what's the mean? 68. That's 2 above. That's 1 above. That's the same, and that's 3 below. So if we were to average it out, it's about an average of about 2. One's a little bit more. So that's what that standard deviation means. That's the last slide. So now, instead of focusing on the calculation part, let's take a look at the homework, and we're going to use our calculator here. So I've got it open, and let's see, Let's go. Ah, got it. Oh no, I don't want to go to the homework. I want to go to the quiz because then we'll have just the 5 questions or so, 5 or 6. Go to teacher preview. It's that bigger, a little bit bigger. Okay. Okay. Second attempt if you need, we'll learn a maximum 7. Yeah, I think I took all those out. So anyway, um, Frisbee Golf Club recorded the ages of members and used the results to construct this histogram. So we've got these ages, we've got how many there are. Find the number of members 25 years of age or younger. So these are 16 to 20, 21 to 25. So it makes sense that we would add these two together to get those 25 or younger. So there's 2 here. There are 7. So should it be not 2 plus 7 is 9. And it's good. Okay, so nothing too. Oh, this is something we didn't talk about. We sort of talked about, but we talked about when you take the mean, how having a number way out can sort of pull the mean higher. So that's what's happening here is, and this actually we'll talk about more, a little bit more in the next section, but it causes a skew. So this is skewed because there is a data piece, you have a data piece way out there. So this is skewing to the right. Now, the hard part of this is I always look at, well, there's a bulge to the left. So I think of it's a skew to the left, but it's not. There's a little piece of data way out here that's skewing it to the right. So it is right. This one's right skewed. This one is symmetrical, right? It's not pulled to the left or the right. Bell-shaped. Okay, kind of, well, looks like a bell. So this one is actually left skewed because most of the data is here. It's being sort of pulled or skewed to the left. And this one is what we would call uniform, and you might just have figured that out on your own by seeing what the options were, but trial and error. But we'll just kind of go through here. That's we don't do a lot with this, but just so you know some vocabulary. Now this is where we get to have some fun. They want us to calculate the mean, median, mode, the range, and the standard deviation. Probably take us about 20 minutes if we did this all by hand. But what we're going to do is we're going to come here. We're going to highlight the data. We're going to do on a Mac, it's Command C. On a Control C on the other one, the PC, right? Windows based. Then we're going to go to our descriptive statistics. We're going to click in there and Control V or Command V. We'll paste it. Cool. And then it's a sample because it's not, and then we're just going to click on Calculate and watch what it'll do. I think hopefully it works. Maybe I have to hit Enter. Nope, I already did. Let's go to Calculate. Notice it put the data in order for us, put in commas for us. We didn't have to do, we just copied and pasted it, and it gives us all our answers, right? So now we can focus on what do the answers mean and just kind of remind ourselves, oh, minimum, maximum, found the small and the large, the range. We've got the size, okay, there's 10 pieces of data, gave us the sum, but it calculated the mean as 116.6. So I can come back here. That's what they wanted, 116.6. It calculated it for me and did it very nicely. Okay. The median, again, I'd have to put it in order, find the middle piece of data, but again, it has done that for me, and it's got this little funky thing, this X. I've never seen that symbol before, but at least it says it's the median, 116.5 as well. And again, since it put it in order for you, you could kind of see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. So 1, 2, 3, 4, 5. It's halfway between 116 and 117. So you could verify this if you wanted to, but yeah, 116.5. And the mode is 130. Why? Because there are 3 130s. So you can kind of see it in the data, but you're also going to get the correct answers as well. And I think part of this is you learn by doing it. You see it. Why is 130? Oh, because there were 3 of them. Okay. So you know, the range, it got calculated. Again, you could just come up here, take the large minus the small, but it has done it for us somewhere here. Oh, there it is. Range is 35. The other part is on the right-hand side here. Look at, they give you explanations. How did they get the range? They took the large minus the small. They kind of, the difference between the minimum and maximum. Oh, they got them here. So, okay. So again, they did it for us, but we're also learning how it happened. And then the sample standard deviation, they give us the standard deviation here. We said it was a sample. Now, if you do population, you'll get a different number, but they told us this is a sample. It's not everything we're wanting. It's just so that's 12.81. See, what do they want it rounded to? To the nearest hundredth. So 2 decimal places, 12.81, 2 decimal places. So we do have to do some math, right? We have to round correctly. There we go. So far, so good. Again, gets us focusing on how we're going to use it. Even this one, find the 5-number summary. Now, we didn't talk about the 5-number summary, but we're going to talk about it now. What we do is we select the data again, even though it's in this table. We can do that. I'm going to do a Command-C or Control-C. We're going to come back to our descriptive statistics. Let's clear it out. If you want to, you could just hit the clear button and it's gone. We're going to paste now, Command-V or Control-V. Notice it puts it here again. When we go to calculate, it puts it in order, puts in the commas, everything. Beautiful. And does all the calculations for us. Now, the 5 numbers we want, this is a different way of, this is when we do a box and whisker plot, which you'll be doing. The 5 numbers we want the minimum, we want the maximum, we want the median. So notice how that gives us the low, the high, and the middle. And then we want what's called a first quartile, Q1, which is halfway between the minimum and the maximum. And we want the third quartile. And so those numbers that we're going to get are, minimum was 4, the maximum was 100. We have to come down here to the median, although they include the median down here in the quartiles. The median's actually quartile 2. So these are the 3 middle numbers, and then I have the minimum and the maximum. So we have 4, 100, and again, your numbers may be different, but as long as you post them in, you'll see it. And then these are the middle, 36, 61, and 72. When I put them in, I have to put them in order. If I get them in the wrong order, I'll get it wrong as well. 31, I remember 62, I remember 100, and then the one was 70 something, right? So I click back 72. Okay. So again, I would have had to put them in order and gone through a lot of things, but it's taking care of that for me. Oh, it didn't like that. Oh, 36 and 61. Too confident. But that's why I give you an extra try, because I'm the one who needs it. 61, right? Yeah. Okay. There we go. Now we got it right. We're all good. So good, the 5-number summary. And then this is what we've done. This is what I was going to, you'll see this question. So I sort of just teach by doing. This is what's called a box and whisker plot. You see the box in the middle, the whiskers. What each of these horizontal lines represent. This one is the minimum. It's the 5-number summary. This is the maximum. This is, we could just call it quartile 1, quartile 2, which we also call the median, and quartile 3. The reason we call them quartiles is they divide the data into quarters. 25%, so there's 25% of the data here, 25% in this section, 25% up here, and then 25% here. So the thing that's a little deceiving is the one that has the most space is not that there's the most data and there's the same amount. It just means that data is more spread out. So you got to look at those, the further out it is, the more spread out the data is, it's still the same amount of data. Okay. So a question like this, if a person is making the first quartile salary for a construction worker, first quartile is right here. So how much are they making? 35,000. They are making more than what percentage of teachers? So then I have to come down here. They're making more than this percentage of teachers. 25 plus 25, right? And your answer is always, that's what we're going to be, is some form of 25% or 50% to 25s. Okay, so we can use those box and whiskers to take a look at. Teacher salaries are more variable, right? Starting teachers don't make so much. Teachers have been around for longer, make more. So there's a greater spread where construction workers. So it kind of gives us a feel for minimum, high, spread. So box and whisker plots are very helpful. And this one just gets us tied back in. And these will all be the same. So in general, blank percent of the values in a data set lie at or below the median. So the median, what percent of the data is below the median? 50%, right? Because that's the middle. It's the physical middle of the data. And then what percent of the values in a data set lie at or below the third quartile? So the third or below, 3/4 is 75%, right? So that's going to be 75%. A sample now here's where we can take this. If a sample consists of 1,900 test scores, blank of them would be at or below the second quartile. This is just a quick calculation. We take the number 1,900 and we multiply it by the 50% as a decimal. 50%, move it over 2 places, is going to be 0.5. And so if we do that, half of those is going to be 950. Right? Half of 1,000 is 500. Half of 900 is 450. Add them together, you're at 950. Finally, if a sample consists of 1,900 test scores, blank of them would be at or above the first quartile. So this one didn't ask question, or no. So at or above the first quartile, well, there's 1, 2, 3/4, 75%. So we take that, this number here, multiply it by 0.75, and we'll just do it. Still a need for just regular calculators. 1425. We got that all right. Okay. And so if you do these, this will give you the basis for doing all of the homework. Again, this is just, 6 questions. Use that calculator, copy and paste, but also take the time to kind of remind yourself, how did we get the mean? We added them, divided. That's why it's getting the median. They located the middle. And that's one of the reasons I chose. There's other statistics calculators out there, but I like this one because it puts it in order for you when you copy and paste it in there. So it's kind of reminding you, yeah, you got to get the data in order to find the mean, the median, and all that kind of stuff. And then it does it all here, and it does it in a way where the calculations are over here too. So you're reminded how it's doing it. You're getting exposed to some of the notation that's used without having to worry or get stressed about it, because you're going to get all the answers over here. Okay, and you'll even get it. I mean, you get some pretty advanced stuff. So if there's this thing called a kurtosis. Can't remember. It has something to do with the skew. And again, it's pretty advanced statistics stuff, but it's all here. And then if you need the frequency table, here's another thing. If you have anything, it'll make the frequency table for you as well. It will make a frequency table. Of course, it sets it up in a particular way. And then more information that you need, you might want to find out. Sound good? And then what we're going to do is on next week, we deal with this, with the normal curve, which we do less calculation. And again, I'm going to give you a visual tool that will help you understand. Where we use it is more for predictive. If this percent of the population has a shoe size of 5, how many shoes, so we can kind of, we use the statistics in that manner, but it'll build off of this basics of statistics. By the time we're done, you'll have about the first 2 weeks of any standard statistics course, at least the content for it. So you'll be able to come into a statistics class with a head start, and then you'll get into more of this advanced stuff. But what our goal here is to give you about a 2-week head start if you ever do need to take a statistics course, but not get you too deep into analysis and everything. All right. Not bad. Only took us about half the time. Okay.